Welcome to Biota.org Interviews. I'm Tom Barbalet, and today I have the privilege of talking with Brig Klyce, who has set up an artificial life prize. Brig, for people not familiar with your prize and your background, can you please talk about how you got interested in artificial life?
Sure. Tom, thanks for inviting me, by the way. I've always been interested in evolution, and then in about 1982 or 3, I got interested in panspermia and the possible effects of panspermia on evolution, and I became skeptical about some of the aspects of Darwinian theory, not about microevolution and adaptation, and not about the history of life on Earth, but about the capability of a system based on encoded instructions to invent new features in a closed system. And previously, we thought that life on Earth was a closed system, but it turns out that life can arrive here. No one's disputing that now. So Earth is not necessarily a closed biological system. And so we can't simply point to life on Earth and say we know that life can evolve and advance and make progress in a closed system because here it is. Well, this may or may not be closed. So how could you find out if a system based on encoded instructions like life or computers can make progress in a closed system? You can design some experiments. And there actually are some experiments in biology. Richard Linsky at Michigan State, I think it is, has something like 35,000 generations of bacteria now, where they started with a cloned species that they knew the entire genomic sequence of. And so that's a closed experiment in biology. But not even he is claiming that those bacteria have invented new features. And so one of the problems about this question is there needs to be a medium where you can run these generations faster than once every couple of hours or once every day. They need to be able to run faster, and computers can do that. So that's how, that was kind of a long answer, but that's how I got interested in artificial life.
Can you give some background to the prize that you're currently offering?
Well, yeah, when you say I'm currently offering, I'm currently promoting it, and I'm trying to recruit a distinguished panel of people who would be more qualified than I to judge entries and know what's going on in an artificial life model. But I have attempted to sponsor research using artificial life models for a number of years, and one of the ideas that I had, and not the only one though, was what about a competition? And I've been promoting this and talking about it for at least 5 years with Mark Badeau, for example. Mark is the editor of Artificial Life magazine. I forgot the exact name of it, and he's the president of the International Society for Artificial Life, I believe it's called. And he has gradually come around to thinking maybe it's a good idea, and it has succeeded even at this early stage in bringing some attention to the question I'm asking, which is evolutionary progress in life or a system analogous to it, like computer models, is evolutionary progress, open-ended progress in a closed system even possible at all? Because people assume that it is possible, and I'm in the sessions where I've promoted this prize, I've at least made people aware that not everybody agrees. Of course, they know that anyway. But you can disagree without abandoning science. And so, all right, I've gone to 2 recent conferences. In June, I went to the A-Life 10 conference in Bloomington at Indiana University, and had a session promoting the Artificial Life Prize. It was attended by about 50 people, and then about a dozen of them came to a second session over lunch the following day to further plan and strategize. But they cautioned me that before we sign up as your board of directors and agree to start accepting entries, we need to further define a lot of our terms. And so the idea that emerged after that was, all right, before we announce a prize and a judging system, we'll promote lesser prizes for papers that would help us define the terms of the prize. And that's basically where we are. And the thing is somewhat stalled at the moment, and I'm a little bit frustrated by it. But I'm still pushing, and I have Jordan Pollack, for one, who was the chair of the Artificial Life Conference that preceded this one, has taken some interest in the question and is helping me. He too is skeptical about getting it defined sharply enough to announce and go forward. But at least he's asking me questions that are helping me think about those issues.
It's a non-trivial problem in artificial life currently, in order to create a purely neutral platform where you can test out these ideas without any ideas of presupposition or implicit assumptions or things of this nature. As you are in a definitional phase, what's your own personal thinking on that issue specifically? Well,
I acknowledge that it's a very difficult question, and the best that I was able to do in the sessions we've had so far was to say, okay, here are some examples of phenomena that would qualify as exemplifying open-ended evolutionary innovation, and some that wouldn't. And the ones that wouldn't probably would come from these non-neutral platforms that you mentioned, where the thing is supposed to find a solution or find an algorithm or piece together some algorithms that would come up with a new subroutine. But the goal is specified in advance, and the system is rewarded for getting part the way there. So it's it's hand-holding to a solution that's prescribed in advance. That does not exemplify what life on Earth appears to have done, and that would be an example of something that I guess is definitely non-neutral. But a neutral one, or even a non-neutral one, if it did something that was not part of its original intention, might still be instructive and to the question I'm asking, which is, can these things, whatever their purpose was originally, can they do things that weren't part of that purpose? That's my question. And I guess it's hard to know. Sometimes it's hard to know what was in there in the first place. And that's what makes it difficult to define a system as neutral and non-neutral, perhaps. Now, I know you've done some background investigation with regards to certain artificial life systems. Can you talk a little bit about that and the issues that you've encountered looking at artificial life? Well, the one that I ever became the best acquainted with was Tierra, which was originally written by Tom Ray. He posted a website about it in about 1995, I think, or anyway in the late 90s. And that one, in that model, he had a creature that consisted of something like 80 instructions, and there would be a population of them, and they would fill up the memory and of the available memory of a computer, and then they would begin to mutate, and more fit ones would replace less fit ones according to some criteria, and so they would evolve. And they supposedly discovered some interesting things, including parasitism. You know, they would merge, or partial ones would merge with other partial ones, and then together they would do things that neither of them could have done on its own. But I didn't think, and I still don't think, that anything has been invented in that example. And in fact, I did talk with Tom Ray in 2001 at some length, and I believe he agrees with me. In any case, he says about his model that it hasn't yet achieved a spiraling upwards in complexity, I believe was his wording. And one of the things that he did was to invent a new version of it called Network Tierra, where I guess they thought, all right, the environment, even in a big computer, is not big enough, but if you had a network where these things can travel in the network then their environment is the whole network, which could be worldwide with the Internet. And so Network Tierra has run for several years now. But still, no one is saying that the creatures have invented some new features for themselves. And I think in general that one, while very instructive and very well known, has not made a breakthrough and demonstrated open-ended evolutionary innovation. I'm trying to remember some of the other ones. Well, at the Artificial Life 10 conference, Chris Adami was there, and he talked about, it's Avita, I believe it's called. And Charles Ofria, who was his main programmer, was also there. And in fact, Charles was one of the dozen who came to my second session. And Chris himself said to me, listen, I can do open-ended evolutionary innovation right now with Avita, and all I have to do to make it completely open-ended is just slow it down so that each thing it does takes a very long time, and that way it'll keep doing them until I'm dead, I guess. But somehow that didn't seem very convincing to me. And I think that Charles Ofria understood the question I'm asking, at least, and he did not say to me, if he had plenty of opportunity, look, we can already do that. So those are two examples, I guess, that I know the best about Tierra and Avita, and there are others, but I haven't read about any of them either that they've started doing something they weren't supposed to do. And as an example of something they weren't supposed to do, Tierra was rewritten in a network version, but it's not unreasonable to wonder if Tierra couldn't have evolved into a network version all by itself and figured out how to escape through the modem, which was already there, or the Internet connection. And that would have been a quite inventive thing to do, but it never did that. And that's the kind of thing that is supposed to have evolved in life, the ability to escape, let's say.
This returns to the problem that I phrased to you with regards to neutrality. The properties that you are looking for are not explicitly programmed, so they will never actually emerge. Can you talk a little bit more about what you would like to see from artificial life developers?
Well, at this point, simply an interest in the question. Someone wrote that assumptions are more striking than ideas, and one of the assumptions that they all seem to have is that open-ended evolutionary innovation in a closed system is possible. And there used to be this feedback that went between the biologists and the artificial lifers, that biologists thought the artificial life has probably already got it done, and the artificial lifers thought, well, we're just trying to model something that we already know happens in biology. But the process, hasn't been demonstrated in either medium. I explained to you earlier that in biology we don't know if the Earth is. We know that the Earth probably is an open system biologically, and then in computer models, well, I've looked at them carefully, and they don't seem to do it. So what I would like from artificial life programmers is to simply say, this is an interesting question, and we don't need to assume something that we don't really know. It may or may not be possible. Let me put it in a negative way, just to see if that helps. This would be, suppose I have a claim or hypothesis that in any system based on encoded instructions, like life or like computers, that whatever is the meaning contained in the original instructions, the starting instructions, the instructions that are there in the beginning, that's all the meaning that will ever be there, unless something comes in from outside. Now, the challenge to the artificial life programs would be, okay, disprove that. Disprove that claim that hypothesis. And perhaps an interesting discussion about meaning and how to quantify meaning, if that's possible, might emerge. But I just think the question is extremely important, and what I wish at this point is that the artificial life community would recognize its importance.
Any final thoughts for the interview, Brig?
Well, once again, I'm grateful to you. I should say that one of the problems I've had, or here are some of the problems I've had in presenting the artificial life challenge, or the evolution prize is what I'm calling it, is that people are suspicious of my motives, and they know that I have a website where I promote a version of panspermia, and that's true, I do. And if there's time, I'd like to talk about that a little bit, not about panspermia, but about how I got so interested in it. My original interest is in this question that we've been discussing. But early on, I remember reading Thomas Kuhn, I guess, and one of the things he writes is that no scientific theory ever just falls on its own weight. There has to be an alternative that is perceived to be better. And with respect to this question, if the answer is no, what is the alternative? Well, I'm proposing an alternative, and it is the strong version of panspermia. But I am, as I promote the Evolution Prize, I just want to know the answer to the question. Perhaps my skepticism is misplaced. Perhaps it is possible for a system analogous to life to generate open-ended evolutionary innovation in a closed system.
You'd be sure to award the prize in that circumstance.
Oh, you sure would. I'd award it and I'd be happy. Happy we all learned something, not just me. I have no ulterior motive except to know the answer to the question. I would like to make another point about panspermia, just because people have a knee-jerk reaction that, okay, maybe Earth isn't a closed system, but we already know that the whole universe is a closed system because there was a Big Bang. And one of the most interesting things to me is that the Big Bang is the only thing that the Darwinists and the creationists and ID community agree about. They both love the Big Bang because they want there to be a start of everything. But if you scrutinize the Big Bang and the evidence for it, it's the most fluid thing you ever saw. I don't know if you remember, but in 1998, the number one science story of the year was about the acceleration of the expansion of the universe. Until that time, people talked about three scenarios for the expansion of the universe. Either it will collapse, or it will just get bigger and bigger, or it's right on the cusp, and it'll kind of coast to a stop. But they were all deceleration scenarios. And then all of a sudden we find out, wait a minute, it's not decelerating, it's accelerating. Well, the Big Bang Theory was not the least bit affected by that. Everybody said, oh, okay, well, that's interesting, but, it doesn't, we don't need to wonder about the Big Bang. We still know that our knowledge is sure. And this is what I say. If the Big Bang is real and life started at a finite time after that without miracles, then there should be some way to demonstrate aspects of it. I mean demonstrate, not just speculate about, but demonstrate. And when I look for demonstrations, they are awfully weak and rare. And if they are so weak and rare, maybe it's not possible, maybe the prize is not winnable, and maybe biology has something to say about cosmology instead of the other way around.
Thank you very much for the opportunity to talk with you today, Brig.
Tom, thank you. I hope I didn't go on too long.
Not a problem. Not a problem.